In this video, I will go over the homework that follows the lecture on graphing in polar coordinates, and as always, I hope that you watched the lecture, and let's go ahead and jump right into the homework. And the first question is to figure out the outputs of the polar equation for certain inputs, and we can do that pretty much. This is the predecessor for graphing, so we pretty much, for some values of theta, plug those values into the given formula and simply compute it. So here we have 7 sine 3 times pi over 4, 7 times sine 3 times pi over 2, 7 times sine 3 times 3 pi over 4, and finally 7 times sine 3 times pi. So sine of pi and 3 pi is equal to 0, so we know this is 0. Sine of 3 pi over 2 is equal to -1, so this is -7. Sine of 3 pi over 4 is root 2 over 2, so this is 7 root 2 over 2. And finally, sine of 9 pi over 4 9 pi over 4, it's 8 pi over 4 plus pi over 4, so again, this is just going to be root 2 over 2. So this will be the values. I'm just going to copy that over here. This is -7, and this is 0. Alright, so next we are going to convert this equation to rectangular coordinates. And we're going to do that by multiplying both sides by r. So we have r squared minus 7r sine theta. Then we're going to recall the fact that r sine theta is y, and also that r squared is x squared plus y squared. So here's what we get. And now we're going to bring everything to the same side, complete the square, and here's what we get. So we have a circle centered at 0, -7/2, and radius is 7/2. 7/2 is 3.5. So this is the center. And it's touching the origin, so this is the graph. Next, we're going to convert this equation into polar form. And to do that, we're simply going to replace x with r cosine theta and y with r sine theta. And we're going to then isolate r if possible. So I have 6r cosine theta is equal to 7y sine theta. Should be r sine theta squared. So we have 6r cosine theta is equal to 7r squared sine squared theta. And we're going to assume that r is positive here. And that means we can divide both sides by r. So we have, and I'm going to switch sides now. So we have 7r sine squared theta is equal to 6 cosine theta. And I'm going to isolate r by dividing both sides by 7 sine squared. So we have 6 cosine theta divided by 7 sine squared theta. And that's going to be the equation. 6 cosine theta I guess we can make it simple. 6/7 cosine theta, and here we have cosecant squared theta. I'll just copy this one. That's the same thing. Now we are asked to move in the opposite direction, and let's undo what we just did. So we have 5 cosine theta divided by 7 sine squared theta. So we have, I'm multiplying both sides by 7 sine squared theta. So we have 7r sine squared theta is equal to 5 cosine theta. And now I'm going to multiply both sides by r. And we're going to replace r sine theta with y. No, x. I'm sorry, y squared. And we're going to replace r cosine theta with x. Now, isolating for x, this is what we get. For number 5, we have to pick the correct answer here, the correct plotting of this 1, 2, 3, 4, 5, 6, 7, 8 points. So let's take a look. We have 3, 0. This one is 3, 0. 1, 2, 3, 4, 5. Actually, no, this is not 3, 0. So it's definitely not the first one. It could be this one. It's definitely not this one. Definitely not this one. So let's just check for other values. So we have 3, 0. What else we have? At pi we have -7. So at pi we have -7. So that's this value right here. And then we have at pi over 2 we have -2. So this is our pi over 2, -2, so it's got to be this one. So we just looked at the 3, 0, -7 pi, and -2 pi over 2. That's all we had to do. Number 6, we have an equation of a line, and we have to convert it into polar form, and we're going to replace x with r cosine theta, and we're going to replace y with r sine theta, and then we're going to factor out r, and isolate r like this. So that's the answer. Oh, we're plotting it. I apologize. So if we're plotting it, that means we just have to plug in some values. And it looks like we only get to pick, no, right here, right? So let's choose theta to be 0. So at 0, what do we have? We have r equals -6 over 4 plus 0, so it's -3/2. So when theta is 0, we have -3/2. It's right here. And let's also plug in theta pi over 2. So then r will be equal to 0 plus 1, so it's -6. So at pi over 2 is -6, so we're gonna go right here. So this is the line. Here we just have to know the shapes of the most common equations, and they are summarized right over here. So when you have sine or cosine of multiple thetas, that's a rose, and that's just something that we need to know. Now if you don't believe me, then you can always just graph it, and that's the rose. If the number of theta is odd, then it's the number of petals. If the number of theta is even, then it's the number of petals is twice as much. So that's just the rule. It's similar to the idea of, in Cartesian coordinate system you recognize parabolas and lines. In polar coordinates you recognize roses, limacons, spirals, and cardioids. Converting this into polar forms, again, this looks like hyperbola, and we're going to convert it by replacing x and y with, we're going to replace x with r cosine theta, y with r sine theta, and then we're going to distribute everything. Divided by r, so, and take out r on the left side. We can actually take out 8r, and we have here cosine of 2 theta equal to 6 sine theta. And now isolating r, we divide both sides by 8, so we have 3/4. And dividing by cosine of 2 theta is the same as multiplying by secant of 2 theta. So this is the answer. So 3/4 sine theta secant of 2 theta. And it looks like we have the same task, but now we have to undo it. Except there's no double angle here, so it seems like we've done this before. What we're going to do is we're going to multiply both sides by 8 sine squared theta. Then we're going to multiply both sides by r. And now we're going to replace r sine theta with y and r cosine theta with x. So x will be equal to 8/6 y squared, which is just 4/3 y squared. And that's it. If you have any questions about graphing in polar coordinates, please reach out.